This video covers graphing quadratic functions. We're going to be looking at standard form of quadratic function as well as the vertex form. A quadratic function in the standard form can be written as f of x equals ax squared plus bx plus c. In equation form, it can be written as y equals ax squared plus bx plus c. F of x and y is the same thing. It's simply saying y is a function of x, where a cannot equal 0. Because if a is 0, then this is not a quadratic function, a second degree function anymore. Here's some examples of quadratic functions. Y equals 5x squared, y equals negative 2x squared plus 3x, y equals x squared minus x minus 3, and y equals negative 2 times x minus 3 squared plus 4. Graph of a quadratic function looks like a parabola. It's a U-shaped graph. The highest point or the lowest point on the parabola is called the vertex. Axis of symmetry is the line drawn exactly in the middle of the graph that passes through the vertex. It's a vertical line that passes through the vertex. If we fold the parabola along this line, we get two congruent parts. Graphing a quadratic function. So graphing the function given in the form y equals ax squared plus bx plus c. First, we want to see direction of the parabola. If a is positive, coefficient of x squared. If it's positive, parabola opens up. If a is negative, parabola opens down. Next, we want to find the vertex and axis of symmetry. To find x coordinate of the vertex, we will be using formula x equals negative b over 2a. And this formula comes from quadratic formula. And that will be also equation of axis of symmetry. Once we have the vertex, x coordinate of the vertex, we're going to plug this back into original equation to find the corresponding y coordinate of the vertex. And that will be our vertex. Ordered pair xy will be our vertex. Next step is to make table of values by choosing two values to the left of the vertex, x coordinate, and two values to the right. And the graph is going to be symmetric on left and right. We can also find x and y intercepts and use symmetry to graph if we don't want to make the table. Here's some examples. Let's look at the first example. We want to graph y equals 2x squared minus 12x plus 10. First step, we want to see that this number is positive. So this parabola is going to be opening up. Let's find x coordinate of the vertex. X equals negative b over 2a, which is negative 2, negative 12. A in this case is 2, b is negative 12, c is 10. So negative b over 2 times 2, which is 12 divided by 4 is 3. So x coordinate of vertex is 3. To find the corresponding y coordinates, we're going to replace x by 3 in the original equation and simplify. 2 times 9 minus 12 times 3 is 36 plus 10. So that turns out to be 9 times 2 is 18. 18 plus 10 minus 36, 28 minus 36, which turns out to be negative 8. So my vertex in this case is x is 3, y is negative 8. 1, 2, 3, 5, 6, 7, 8. So that's where my vertex will be marked. X is 3, y is negative 8. Next, we can either make a table of values around the vertex, or we can go ahead and find x-intercepts and y-intercept and then use symmetry to make the graph. In this problem, I'm going to go ahead and make the table. So I'll pick two values to the left of the vertex and two values to the right of the vertex and find the corresponding y values. When x is 1, y would be 2 minus 12 is negative 10. Negative 10 plus 10 is 0. And I know my graph is going to be symmetric, so I don't need to find all the corresponding values. I just know when x is 5, y will be 0 again. Now I want to think about when x is 2, what is y equal to? So let's go ahead and replace x by 2 in the original equation. When x is 2, y is going to equal 2 times 4 minus 24 plus 10. 8 minus 24 plus 10, which is 18 minus 24. That's going to be negative 6 and negative 6. Let's go ahead and mark these points and connect the dots, and that would be our parabola. We also want to list our axis of symmetry. We have the vertex here. So next point would be 1, 0. X is 1, y is 0. And x is 2, y is negative 6. And we can also use symmetry. X is 4. When x is 5, y is 0 again. So this parabola is going to look like this. Remember, parabola does not have any sharp points. It's going to be a smooth, rounded curve. Okay, so parabolas are always smooth, rounded curves, no sharp corners. And axis of symmetry in this case will be x equal to whatever is the x coordinate of the vertex, which is 3 in this case, because that's going to be the line exactly in the middle of your parabola. If we fold our parabola along that line, we will have two congruent parts. Next example. In this case, parabola opens down because I have a negative coefficient for the x square. To find x coordinate of the vertex, we're going to be doing negative b over 2a, which is negative 6 over 2 times negative 3, 6 over negative 6, which is negative 1. So for my vertex, the x coordinate is negative 1. Let's find the y coordinate of vertex by plugging negative 1 for x here. Turns out to be negative 3 plus 6 minus 9. And that's going to be negative 12 plus 6, which is negative 6. So we have our vertex, negative 1, negative 6. One more down. Okay, 1, 2, 3, 4, 5, 6. Negative 1, negative 6 is my vertex. We can go ahead and make a table. We can also find x and y intercepts to make the graph. So negative 1, negative 6. Pick two values to the right, two values to the left, and we don't need to find all four. We don't need to do calculations for all four of these. We know they're going to be symmetric, so we can just find any two and go from there. So let's go ahead and find when x is 0, what is y going to equal? Y is going to equal negative 9. Same thing when x is negative 2, y would be negative 9. Let's see when x is 1, what is y going to equal? When x is 1, y would be negative 3 minus 6 minus 9, which is negative 18, negative 18 and negative 18. Now, this parabola opens down, and I don't have enough space to show that. When x is 0, y is negative 9. So I'm just going to be marking by estimate, and I must label the points. So this point was negative 1, negative 6, and this point is 0, negative 9. This is negative 2, negative 9. And then I have 1, negative 18, and negative 9, negative 18. And axis of symmetry in this case would be x equals negative 1. That is the line that passes through, that cuts the parabola in two congruent parts. Next, we're going to look at the vertex form of the quadratic equation, which is written as y equals a times x minus h squared plus k. hk is the vertex. And then once we have the vertex, we can either make a table by picking x values around the vertex, or we can find x and y axes, x and y intercepts, and use symmetry. Okay, here's our first example in the vertex form. So if we compare it to y equals a x minus h squared plus k, again, if this a is positive, the parabola opens up. If a is negative, parabola opens down in vertex form as well. So in this case, the vertex is going to be 2, 5, hk. H is 2 here, k is 5. So vertex is h is 2. 1, 2, 3, 4, 5. That's where my vertex is. And we can see this parabola is going to open up. And I don't need to bother to find the x-intercepts in this case because I already know this graph is not going to have any x-intercepts. It's going to open up. So I'm going to go ahead and make a table for this parabola. X equals 2 will be axis of symmetry and direction this parabola opens up. So let's go ahead and make a table for x values around the vertex and find the corresponding y values. My vertex is x is 2, y is 5. We can pick 3 and 4 and 1 and 0. When x is 0, y is going to be equal to, let's go ahead and plug. When x is 0, y is equal to negative 2 squared plus 5, which is 9. So when x is 1, let's see, what is y equal to? Y is equal to 1 minus 2 is negative 1 squared plus 5, which is 6. Let's go ahead and mark these points. And x is 1, y is 6. X is 3, y is 6. X is 0, y is 9. So that's how my parabola is going to look like in this case. It's a parabola opening upwards. Even if I try to find the x-intercepts in this case, I'm going to get in some kind of trouble. I will not be able to find the x-intercepts. Let's also practice finding x and y-intercepts. If I were to find the x-intercepts, I will plug y as 0. So if I replace y by 0, x minus 2 squared plus 5, which is negative 5 equals x minus 2 squared. When I take square root, I will be taking square root of a negative number, so not a real solution. There's no real solution because I'm taking square root of a negative 5, which is not real. And if I find, so that means there's going to be no x-intercepts in this case, but to find y-intercept, I could use plugging x equal to 0. To find y-intercept, I could go ahead and replace x by 0 in the original equation. So negative 2 squared plus 5, which is again 4 plus 5 is 9. And that's what we got as well. We could use xy-intercept and symmetry and vertex to graph, or we can go ahead and make a table. Another example of graphing in the vertex form. In this form, in this one, we can see my parabola opens down because of the negative in the front. There's a coefficient a is negative. Now, I need to figure out my vertex, which is going to be negative 4 and 1. So let's go ahead and mark x is negative 4, 1, 2, 3, 4, and y is 1. And axis of symmetry will be x equals negative 4. Now I can find x-intercepts in this case, but they're too close to x-axis and it wouldn't give me a bigger picture of the graph. So I'm going to go ahead and make a table. Pick some values around the x, around the vertex, x coordinate of the vertex. So we can pick negative 4, we can pick negative 3, and I want to pick a little farther value so that I can see bigger picture of the graph, negative 5 and negative 8. So when x is 0, y is going to equal, plug x as 0, y will be negative 16 plus 1, which is negative 15. And when x is negative 3 plus 4 is 1 squared, y will be 0. So here's my other graphs, other points for this graph, and I'm just going to mark all the way over here somewhere that using symmetry, my parabola looks like this. I'm going to be labeling all these points. The vertex coordinates were negative 4 and 1, and this point was negative 3, 0, and I had negative 5, 0, 0, negative 15. If I want to find coordinates of this vertex, let's think about it. The y coordinate is not going to be different, but the x coordinate will be different. So I'm exactly in the middle. This is negative 4. From negative 4, if I go to the 4 to the right, I'm at 0. If I go 4 to the left, I would be at negative 8. And that's our graph for this equation. Now we are given a graph, we want to write equation in the vertex form. We can clearly see the vertex 3, 4 here, so we can plug h as 3 and k as 4. And we are also given another point on the graph which we can use to figure out the coefficient a. And we know it's going to be negative, the a is going to be negative because this parabola is opening down. So let's replace h by 3, x minus 3 squared, plus k, which is 4. Now this equation must satisfy the point on the graph, which is 5, negative 4. So we're going to replace x by 5 and y by negative 4 to find out the a. X by 5 to find a. Negative 4 equals a, 5 minus 3 is 2 squared plus 4. Negative 4 equals 4a plus 4. Negative 4 equals, we can actually divide both sides with the 4, and we will get negative 1 equals a plus 1. A is negative 2. So equation of this graph is negative 2. We're going to replace a by what we just found, the value of a, x minus 3 squared plus 4. Next, we're going to see how to convert standard form to vertex form and how to convert vertex form to standard form. Let's first look at converting vertex form to standard form. To convert vertex form to standard form, all we have to do is we can just open up the bag, FOIL, x minus 2 squared, which is x squared minus 4x plus 4 plus 6. So negative 3x squared plus 12x minus 12 plus 6. Turns out to be y equals negative 3x squared plus 12x minus 6. And that is in the standard form. So we went from vertex form to standard form, and both of these are equivalent. We can use any one of these to graph. Next, we're going to convert standard form to vertex form. For that, we will be completing the square. We'll have to use completing the square method. This 3 does not complete my square, so I'm going to go ahead and add the number, which is half of b squared. Negative 2, half of negative 2 squared is going to be negative 1 squared, which is a positive 1. So I'm going to, because I'm adding 1, I'm also going to subtract 1 to make sure I'm not imbalancing the equation. Now I do have a perfect square here, and that's my vertex form for this equation. And both are equivalent. We can toggle back and forth between the two forms. That was all about graphing quadratic functions.